purpose of this video is for you, based upon a reaction or lack thereof, make deductions about ionic solution's identity. Now, an ionic solution has an ionic compound dissolved in it. It's the solute. It's something like NaCl, and the identity is basically what the cation and what the anion are. Now, here's a general outline for the research that you had to do. You've got two solutions, and what you're going to need to do is to check the opposite pair's solubility. What that means is you're going to look up on your solubility chart and check the cation from one solution with the anions or anion of another solution to basically see if they're soluble or not. And then based upon what happens, you'll know what has to be there. Now, here is a web map of the potential outcomes that can happen and what deductions you can make as a result. First thing you're going to do is you're going to mix them. And then you've got two basic outcomes. Either there's a reaction or there's no reaction. And no reaction would be like no precipitate, no color change, no bubbling. The same thing would be for a reaction. It would be the presence of those things. And if there's nothing, no precipitate happens, then, or you see no reaction, then no insoluble chemicals are present. And on the reverse, if there's a reaction, then there's no unsuitable partner or no insoluble partners present. Now here's an applied example. Here are two solutions, solution A and solution B. They're both going to have a cation or anion, cation and an anion, and there may be more than one of each. And that's why we're studying its reaction. So here we've got potential two cations. There should only be one present in the problems that we're going to do. In real life, there could be multiple cations in one solution. Here we've got two cations. Right, and there are anions. Now, when it gets to the research, you're going to want to compare the solubility of these cations and these anions, and these cations with these anions. Now, if you remember, nitrate's one of our potential anions. It's soluble with everything, so I don't need to worry about, I know that about this and these, and sodium is the same. It's also very soluble. The only insoluble thing is silver with chlorine or hydroxide. So I've done my research. I know what's soluble and what's insoluble. Then I'm going to have to mix them. And based upon what happens as a result, I'll be able to figure out what's in there. Let's pretend I don't see a reaction. That would confirm that silver is not there. Because if silver were present, it would react and you'd see something. So if I put them together and there is a reaction, I can deduce two things. Silver is present here, and chloride or hydroxide has to be present in solution B. Okay, here's another example. Once again, I've got four potential cations, two in each. And this time, I've got three potential anions in each. Now, I'm going to do my research. Lithium is highly soluble. I figured so it's always dissolves. So is nitrate with these two. Then I need to check out how chlorine is, how soluble, not chlorine, but calcium is, and how soluble strontium and iron are with these anions. And I figure out that calcium and chloride and bromide, calcium chloride and calcium bromide are both soluble. And strontium is soluble with these two things. I've already established that calcium is soluble with nitrate, as is strontium. And then the only insoluble thing that could be present would be iron hydroxide. So then I mix them, and let's say I see a reaction. That's going to confirm the presence of iron here and OH there. And on the flip side, if I don't see a reaction, that's going to confirm that strontium is present. Only that strontium is present here, and it's not iron. Now here's a third example. Here we've got two potential cations and two potential anions, 1 and 3. So I'm going to do my research. Sodium, very soluble, as is nitrate. Potassium is another highly soluble. All those group 1 metals are very soluble. And so the only thing I'm concerned about is magnesium. Not that only thing I'm concerned about. The last thing I need to look up is how soluble magnesium is with these 3 anions. So magnesium is soluble with iodide, but it's insoluble with carbonate or hydroxide. So when I mix them, I'm gonna have some potential outcomes, 2 potential outcomes and 2 potential deductions. Once again, if you have a reaction, that confirms the presence of something that's insoluble, it's unsuitable to that cation. The only thing that could do that or would explain that in this scenario is magnesium and carbonate or magnesium and hydroxide. And if I don't have a reaction, all you really know is that magnesium isn't present in solution E.